So, we are going to talk about how to find antiderivatives or integrals by hand.
Oh,
I showed you how to do it on the calculator. This is the basic ones. Tomorrow you have to learn how to reverse the chain rule with U substitution. Don't you feel lucky about that? You will not reduce the product rule. That's for Calc 2. Coleman, you might not have to do that. Based on what you want to do. Sorry, Noah, you're going to have to learn it later. So, with the taking a derivative, so let's say we had ax to the n. When we take the derivative, we multiply and we subtract 1 from the exponent. Well, if I'm given y prime, I have to reverse that. Or actually, I could think of it like going up. So I have to add 1 to the exponent. And instead of multiplying by that new exponent, I divide by it. That's the n plus 1. So I've added 1 to the exponent. Let's do it with a couple of examples. That'd be x to the fourth divided by 4. Because I'd multiply by 4, cancel my 4s, reduce the power. So if I'm looking at this, remember that integrals must always have a dx telling me what my independent variable is. If you keep going, you end up with constants, essentially. You can treat y as a constant. But this becomes x to the fourth over 4 plus c. Okay, do you have your derivative sheet handy? Your packet? Yeah. Okay, pause this. Okay, so now we're going to do a few, and we're going to need this derivative sheet for a lot of these. So this one, what becomes my exponent? And then I divide by 6, and we always add the plus c if doesn't have the bounds on the integral. So with this, do you remember the trick on these square roots? So it's x to the negative 1/2. I guess I don't really need the 1. Now I add 1 to the power. Dividing by 1/2 is the same as multiplying by 2. So these aren't so bad so far, are they? This would often be thought of as U substitution, but it's kind of easy enough that you don't have to. So what's got a derivative of e to the x? The chain rule would say I would have to multiply by what? So I'll divide by -3 instead. And the only chain rules you'll have to worry about for today are going to be numbers. When you start having functions, it becomes more complicated, and we'll work on that tomorrow. What has an integral of cosine? sign. This one would also have a chain rule, right? So you normally multiply by half. X over 2 as a derivative of half. So I'm dividing by half or multiplying by 2, and I have my plus c. Okay? I'm gonna clear this. Does that kind of make sense? So you take kind of taking and you're looking at, well, let's do a really common one that's going to show up. There are a couple more common ones. What has a derivative of secant squared? And so this is just tangent x. This is another common one. What has a derivative of 1 over x? Okay. Oh. Oh. So this is, you'd seen that this is ln absolute value of x. Usually we don't actually write it when we're doing derivatives, but the absolute value becomes important here because 1 over x can have negatives in it. But the ln, if you remember from pre-calc, the domain is only 0 to infinity. So we can't take the ln of negatives. You can in this context, so it becomes an absolute value. Okay? There's only kind of one more thing going on here. I'll do it in a different color because we're going to leave. They have these kind of funny slope fields in the book, and they introduce differential equations where you have a dy dx and you separate and stuff. We're going to leave that till next week once we've got the basic integration down. Before we start, I just don't agree with doing those. I think it complicates the issue when you haven't had enough practice. So we're going to start with, this is the basics. Make sure you actually practice this today because tomorrow we're going to get out of the basics. We're going to do substitution, which is hard. So, just like when I did derivatives with pluses or minuses, I can just do term by term. Do you remember from the week before break why we had that plus C? Um, So I'll simplify this for a second. The twos cancel. So this is my final answer. But this plus C was about if I had this and I said find the derivative, I would get, because there's some constant can go away. Right. Goes away, its derivative is 0. So that plus C is saying for this would be the derivative essentially for if there's any constant there. And where we're going to go next week when we do differential equations is we'll say, here's some initial conditions. Find what that C was. Okay. And you just plug in. It ends up being essentially a little algebra 1 tacked onto the end. And it's not hard to do. It's sometimes hard to remember. So please build that habit of putting the plus C. It matters. It's important. It's an important habit to get into for certain applications. That kind of makes sense. So that is taking integrals by hand. Actually, not that hard, is it? Now you get to practice. Or I guess finish your notebook check and then practice.